avoid bumping into each other, and they wander off into the distance, which is probably not what we want. We want them to hang around each other as well. So we're going to have to add an extra couple of rules to get them to come back around to where the other agents are. First thing we're going to do is go to the body page, and we're going to extend their field of view in the vision tab to 360 degrees, because they may need to look behind themselves to find the other agents. Okay, now that does affect the rules that we've already got. The reason for that is because now these fuzz ranges here represent a 360 degree field of vision, and before they were covering 180 degrees. So what we do is we transform them with fuzzy transform. We just make this the scale 0.5 and hit accept. Now we can see that these curves cover a narrower part of the range, because the range is double, so that's now appropriate. So we should get the same behaviour that we had before, and indeed that's remarkably similar. So our new rules are going to need to refer to extreme left and extreme right. So let's add those. This can be extreme left, we'll just call it X left, and we'll bring on extreme right, X right, and we can set those appropriately, something like this. We can arrow up through our curves to get the right ones. Oops, didn't plug that one in. Now we can find that one. Okay, so it covers all of the range that X left covers all the range that right does, but it goes right up to the edge. Okay, now let's make a little bit more room in here for our extra rules. And another thing we're going to have to add is basically when there are no agents nearby, they're going to have to find agents that are more distant. So we're going to add something called nearish. And nearish is going to start at 0 like that, or 1, sorry, which is a close agent, and then about 0.75, and then out to distant. So it drops off into the distance, and it's most prominent where near falls off. Alright, let's try and make our rules. So if X left and nearish go left, I'll give that a name, X left and nearish, then we've got if X right and nearish go right, so we'll call that X right and nearish. But what are we missing? We only want these rules to happen when none of these are true. So, just give us a little bit more in. Let's make a rule that tells us when none of these are true. Well, the best way to do that is to get an and then we can go not this one, and not this one, and not this one. So that tells us nothing near. Right. Then we can feed that into there and there. So now these ones will only have an effect when there's nothing near. Let's see what happens. Well, they're avoiding each other, but they're still wandering off. And why is that? Well, as they get further away, we find that they're often activating left and right. They want to turn left and right at the same time because there are agents to the left and to the right. If we look on our fuzz nodes here, we can see that it's quite likely that there are R agents out to the left and R agents out to the right that are nearish. What do we do about that? Well, instead of making an average weighted decision over the 3D fuzz nodes here, we really want our agent now to make a clear choice between those. So we click on max and we get a whole different decision going on. Now they're going to avoid bumping into each other, but then when it comes time to turn, they'll make a decision one way or the other. And it's sometimes a bit jumpy because it could be a very slight difference between the two. And if we look closely, we'll see sometimes the agents are a little bit jumpy there. So what we can do is we can put in a filter value in our output node. I'll just set that to about 0.3. Now that's going to cause the changes to be a bit smoother. Even though they might be changing their mind quite rapidly, the end result is a smooth turning value. And so our agents are able to not bump into each other, but thanks to the extra couple of rules, they're able to stay close together.